Okay, class. Sorry for waiting, huh? Okay, so we start chapter 8 today. Yeah, regarding the homework that I asked you to try last week, two questions, I forgot to send to your WhatsApp. We'll send later, yeah? Okay, now we get ready, 8.1. Okay, so this is the kinematics of linear motion. First of all, okay, just a minute now, guys. Okay, you're asked to describe the position of each of the following points with respect to O, origin here, meaning that taking north as a positive direction. So if taking north, can you see going to north is a positive. So you see you are given OP, right? So means you just explain that P, right? OP to the north, right? So 10 meter to the north of O. So I read, you write down, huh? Okay, you just tell that 10 meter to the north of O. Got it? Now what I meant is, wait now, class. Okay, so it said 10 meter to the north of O, because you're asked to assume starting from O. Okay, next, what about B? So I just give you a few in here. So, okay, wait now, sorry. B, okay, can you see with the negative, right? So if negative, you don't write negative, you just say that 5 meter. Yeah, because the direction. So negative to the south of O. Don't apply negative, okay? Because the south is already represent the negative there. Okay, can you follow? So C and D should be okay, right? C, 7.2 meter to the south of O, and D, 14.5 meter to the north of O. Should be okay, right, guys? Yeah. Now we continue question 2. Excuse me. A particle moves in a straight line, passing through the fixed point O. Okay, now we start the displacement. Displacement is as given. So class, displacement is for us to find distance. The difference between displacement and distance is displacement, okay, we can write negative, but distance, we don't write negative. Okay, take note of that. Let's wait for a while. Now, so if you are given S like this, it's quite easy. Assume that motion to the right is positive, see? So if motion to the left is negative, so meaning that, okay, when see T0, T0 means you apply to 8T minus 2T squared. So S is 0, okay. I think you also already learned how to apply direct to a calculator for checking, right? All of you still remember? So S is 8T minus 2T squared, for example, A, when T is 0. Then you substitute here, S, you get 0. Okay, the same thing when T is 2. So you apply 2 here. 8 times 2 minus 2T squared. Cannot 8 times 2 minus 2t squared. Then you get 16 minus 8, you get 8m. You still remember how to apply to your calculator, class? Okay, just to do some revision with you for using the calculator. For you that are using EX, you key in your calculator for 8 alphabet x minus 2 alphabet x squared. And then you can go calculation, direct to your calculation, 0 equal. And then after that, calculation for 2 equal like this. Meaning that, okay, wait, so for you that are using EX, also the same. Just a minute, I show you what it is. Any of you forgotten how to apply? Later when come to the table, more than, maybe a few values that given. So your advice to use this way to find will be easier. Just a minute, Okay, then you apply like this. 8 alphabet x. Same, EX1 minus 2 alphabet x squared. Then because of many values, you can go direct calculation, 0 equal. Then you get 0. Then you go calculation 2 equal. You get 8, you see? Then I just show you already, right? You get 8. Then this one. Cannot. Then you go direct. Okay, wait, You go calculation 4 equal. Then you get 0. Calculation 5 equal. Then you get negative 10. Okay, now this is the way how you apply with the calculator. If the expression is the same and you got many values one. Okay, got the class? Now, like what I meant, this type. Okay, you see, a particle moves. Wait, now I'll show you how. A particle moves in a straight line, passing through the fixed point O with the displacement. And you're asked to complete, right? So you do like just now, okay? 14t, you want to do manually up to you, x. I put all the x here, 7 unknown with the x square. Okay, so you go direct. Calculation, 0 equal. Sometimes this calculator a bit problem. Wait, So you go calculation, 0 equal. Then you get 0, okay? Next, 1, So you go calculation, 1 equal. Okay, you get 7. 7, okay? Calculation, 2 equal. You get 2. Calculation, 3 equal. Wait. Big mistake here. Okay. You key in again. Because this calculator is not the actual MS, Hold on, class. 14 alphabet x minus 7 alphabet x squared. Just now I go 3, right? Calculation 3 equal negative 21. Calculation 4 equal. Then you get negative 56. Okay, in class? So now to apply this already, I actually taught you before, right? So can follow all of you? Yes, okay. Okay, anak class, so take note of that. Number 3, remember how to apply already? Yeah, okay, just how I mentioned already. Remember the way. I repeat this one, very important, because you're asked to find the range. After you feel t is 0, t is 1, 2, when t is 3 and t is 4, to get the displacement here. So again, right of O. Right of O means without the negative value, this range of time. So when you write termasuk 0 and 2. Okay? Again, when you see the initial, take note. See the word of initial. Always remember when t is 0. So when t is 0 here, the displacement that is 0 meter. Okay, just I say right of O. Now can you see left of O? And see the word begin again? Begin. So you don't tell 3, starting from 2. Beginning from 2, it start to have the negative value, means because here 0, 2.1, 2.2, and so on, you get the negative value. Okay? Okay, next, we go number 4. A particle moves in a straight line, same, you are given a displacement. Where, okay, t is a time in second, so you're asked to sketch the displacement time graph for the first 4 seconds. Okay, same like just now, class. You make a table like question 3. Okay, wait, make a table like question 3. So you do like just now. You key in your calculator from the value of t in second, displacement. First 4. Can I say first 4? Okay, you get the value of 0 until 4. By using this formula, this expression. Okay, find these 4 values first. Just now you apply to your calculator like just now. T squared minus 5t plus 6. Same, when you go, calculation 0 equal. There you get 6. So keep doing the same thing. 6. Okay, go calculation 1 equal. Calculation 2 equal, 3 equal, and so on, okay? So I go calculation 1 equal. I get 2, 0, 0, 2. Okay, all of you can get this value? Okay, next to class, listen to me. Now, how are we going to sketch? So this is a displacement time. Yeah, one more thing, class. Okay, because this is quadratic. Quadratic, we know is a smiling face like this, right? Then when you have this value, so you're advised to do what? Because you want to see the minimum part, the minimum value, you find this value, 2.5. Okay, 2.5 from a calculator. Right, key in again and see, calculation 2.5. Then I get negative 0.25. Can you see? Negative 0.25. So means I add one value here. Then I know that, okay, between these two, we go a bit down here. Yeah, okay, so you see, sketch quadratic, where when x is 0, I mean t lah, yeah, so you get 6. Then here, 2, 4, 6, wait, 0, so means when 1, I get 2, the value, can you see? So here, 2, 3, 4. Okay, wait, this one 2 then 3 means here I got negative 0.25, this value. Yeah, negative 0.25. So you know that a bit down here. So this value will show that negative 0.25. Okay. And when come to 4, it's 2 only. 2 only. So means that, okay, you can draw onto here. See the value that given means for the first 4 seconds. Okay, and then class, don't forget the label. Label the graph. Okay, can you understand here, all of you? Yes, okay, good. Then find the distance traveled. Okay, wait, so, okay, students, we've got students that still doing. Now y'all draw first. Sketch, actually, this is sketch. Okay, the rest of you can follow, yeah? Okay, after you have sketching done, so you're asked to find the distance. Find the distance traveled with a particle in the first 2 seconds, First 2 seconds. So first 2 seconds, okay, normally some reference book will teach you how to use, the integration or what, right? But for me, I like to teach you all this way. Easiest for you to understand. Okay? Because you want to use the chapter of the integration one, that one pun boleh. Yeah, that one pun boleh, but that one later only I show you. Because to me, the easiest way to get the distance, I like to do number line way. Okay, you see how I do. I advise my students always to use this method. Easier. Okay, we see, Now you do like this. So means when t is 0, you are at 6. 6 meter. See, I got 6, 2, 0, and negative 0.25. Okay, here I put the negative. Actually, the distance, we got no negative one, right? But what I sketch here is the displacement. Okay, see, when t is 0, the particle is here. Next, after that, when t is 1, the particle is here. When t is 2, the particle is 0. Then when t is 2.5, it'll be here. See that? Okay, next, when t is 3, it's at 0. And when t is 4, it's at 2. And then now, class, you see how I sketch, Okay, the particles move like that. Move like that. Then, okay, make a turning. Make a turning. And then move here to stop. Okay, so class, for this chapter, most I will use this method to show you. So now look at what I'm going to explain to your class. From here to here, okay? So means the distance that move lah. They are asked to find what? Particle in the first two. First two, wait, I make one mistake here. Sorry, this is 2, T0, see? T0 at 6, T1 at 2, T2 at 0. Okay, see the yellow line. The yellow that I have shaded means move to here, from 6 move to 0. So, okay, you tell that 6 meter. Maybe you got one question. You say, hey, why not you look at direct to the table? Okay, I'm not going to teach you to get direct from the table because you might confuse. Yeah, when question asks for maybe more distance. So what I show you like that, can you see? From 6 move to 0, 6 meter. Okay? Next, you see here. At what time is the particle at its furthest to the left of O? Can you see? Furthest to the left of O. So can you see here? 0.25. Then it moves here. Moves here. Okay? Moves here means you see this. Left of O, 0.25. Can I? So means for C, you tell that because the question asked it about, the distance traveled 6 meter. But here, not mention the distance traveled. Mention at what time, right? At what time? So you tell that the T is 2.5 seconds. Okay? Furthest to the left of O. Then find the instantaneous displacement at this instant. Displacement, yeah? They asked displacement, not distance, right? So it said that the displacement is negative 0.25 meter. Negative 0.25 meter. Okay, got what I mean? That's why you must know how to answer, whether answering the questions for distance or displacement. Okay, look at D. Yeah, just now I have drawn this. The main purpose for me to teach you to draw this one is to get total distance. Okay, now you see the yellow one? 6 meter. See the red one? 0.25. Red one is 0.25. So I show you. Then this one also 0.25, right? See that? This one also 0.25, right? So class, meaning that 0.25, I make it times 2. Or you can write 0.25 plus 0.25, doesn't matter, yeah? Okay, one more part. Can you see here? Another 2 meter, can you see? Another 2 meter, moving for another 2 meter. That's why here we say plus 2. This is how I get the total distance. That's why I sketch this number line. It's quite easy for you to see the changes of direction and the distance traveled. Okay? So you get 8.5 meter. Okay, got what I mean, class? Can follow all of you? So another one that I want to show you. Okay, can follow in that class? Can I have a response? Whether you can follow or not? So give me your response, George, okay, Yansin? Okay, Yansin. Chia, okay. Red, okay. Sadana, okay, okay, good. So the rest of you know, okay, now. Make use of this. I explain another one to show you. Sometimes, class, for this type of questions, if you're not asking to get the table, okay, how you do, listen to me. Same as what I'm going to explain later. Here will be used for coming quite a lot of questions like this. Now, first of all, okay, you find ds dt. This is another method. Listen carefully. ds dt, okay? 2t minus 5. When question asks you to find total distance, okay, not always you have to do all these values, no need. We need 3 points only. Starting point, turning point, ending point. Okay, no need to do all these values. No need to show all these values. Okay, I show you this one. First of all, you get ds dt. I hope you still remember what is this. Can you see? Minimum or maximum point, remember? Minimum or maximum point. To get minimum, this one means we move to the minimum or move to the maximum point. ds dt is 0. When ds dt is 0, t is 5 per 2, that is 2.25. Yeah, is to show you the particle turns at which point. So means we can find the t. I repeat, when, okay, this one means when ds dt is 0, is for you to find turning point. I hope you still remember the meaning of turning point. Because got two types for the question here. Sometimes the particle moves one way only, no turning point. That one later I teach you. So if you can find the t means got turning point. Turning point means will turn from right to left or from left to right. Without turning one, later when I show you. Because for this chapter, most of the question will have turning point. Okay, so now I have starting point t0. Always starting point t0. Turning point t 2.25. Then ending point t is 4. So you just need to find these three only. Okay, you see? T0, S is 6. T, that 2.25, just now I taught you how to get ready. Sorry, turning point. Turning point, right? Okay, T is 2.5. Sorry. I made one mistake here. 2T minus 5. Wait, I make one mistake here. I'm sorry. 2.5. 5 row 2, 2.5, yeah? Sorry. Sorry, 2.5, yeah? Okay, 2.5, your S is negative 0.25. T4, S is 2. Means class, you find these three only enough. Enough for you to get the value here. Okay, now you see how I do? So same, I will do the same thing. But I just need these 3 points only. Starting point, 6 meter. Turning point, 2.5. So I make it 0, negative 0.25. Then I go turning point. Starting point, turning point, ending point, that is 2 meter. You see, I don't need to find all this. Then what I do? To get a total distance, okay, from here to here. After that, from here to here only. Now, so you see the green one. 6 plus 0.25. So that 6 plus 0.25. Here, 2.25. Can you see the orange one? 2.25. But actually it's the same, you see? Actually it's the same, 6. 0.25, see that? And here also 0.25. What I meant now, okay, see here 6, 0.25, 0.25, and 2. So there's no need for you to find all the points. You just need to get 3 points: starting point, turning point, and ending point. Okay, got rhyming class? It's okay, when come to another chapter, another questions, I'll show you this only, not all the points, unless the question asks you to form a table. Okay, got the class? Can follow so far? Okay, so I want you to have a try and see question 5. Question 5 is more or less like question 4. Okay, wait, I delete this. Okay, I look at question 5. Okay, same as this one. Sketch a displacement graph. Yeah, sketch a displacement graph. But when sketch, you need to do like just now to get a table. Cannot? To get a table. And after that, you do the same thing. Find the total distance traveled. Okay, have a try and see question 5 now. You refer question 4, yeah? Oh, okay, George. You can't follow, is it? Okay, tak apa ya, I explain to you. Class, since got students that not so sure how to do, so I make use of question 5. Okay, to explain again. George, actually you follow question 4. Wait, you see? This part is okay, right? This part to get from the table, I mean the calculator. Wait, you check with the calculator. I mean the value here, whether it's correct or not, you let me know. If it's wrong, I show you via my calculator. If it's okay, I proceed to the other section, George. So 4 seconds also. The rest of you also check the same thing. I got 6, 1, 0, 3, 10. Just to make sure from here. Can you get this value or not, George? Can get another, George? Yes, okay. So what about the rest of you? Can get this value? Okay, see how I sketch, George? So remember just I said, you want to get the minimum value because you're not sure. Just now I show you with the 2, 0, then from there you can find the minimum value, right? So for this, your advice to do like this, okay? You go ds dt. Like just now, ds dt, 40 minus 7. So we're going to get the minimum or maximum value when ds dt is 0. Then we can find the t, right? 7 per 4. Okay, means 1.75. Meaning that the minimum value occurs here, 1.75 when t is, okay, somewhere here, 1.75. Okay, the same thing. You key in your calculator and see. T is 1.75. Then I check 2 times. So I get negative 0.125. Here, negative 0.125. So the other going down, other going down, okay? So see how I sketch again, George? 6 from 6, Same as just now, ada ke bawah sedikit. So here, when t is 0, you got 6. T is 1. T is 1 here. Okay, you got 1. Wait, I make it just a minute, class. Here, 1. T is 1, you get 1. T is 2, 0. And here, this value is negative 0.125. Okay, this value. 3, now you get 3. 4, sketch saja lah ya. 4, I dapat 10 lah. This point makes 10. Okay? Can you understand so far? So we have sketched this. So because of here, if you apply direct like this, you can't get the minimum point. Yeah, remember to apply ds dt. Next, find the total distance. Okay, we see how to get the total distance, yeah? Okay, find the total distance traveled in the first two. In the first two, so we see first two. Okay, same. I sketched the number line like just now to show you. Okay, see how? And just now I taught you to get these 3 points will do. Starting point, turning point, ending point. Starting point means when t is 0, you're at 6. T 0, you're at 6. Turning point means t is 1.75. Turning point. A bit different with just now. I don't get all the values already. I get starting point, turning point. Here I got negative 0.125. Ending point, that is 10 meter. When t is 4. Okay, see how I sketch, class? Okay, so class, what you need to do is, you're asked to find first two. See? First 2 seconds only. First 2 seconds from 6 to 1 to 0. So now, first two, I think it's not that hard. Okay. So first two, what did you get, class? 6. 6 to 1 to 0 meter. Now this one is 1.75. 1.75. Okay, so until 2, you're back here. This one actually is for the last part. Last part, sorry, for the first 4 one. First 4. I made this, okay, wait. Before I continue Roman 1, 2, and 3, I want you to understand if question asks you to find all the first 4, yeah? So listen to me first, class. Let's say question asks you to find first 4. Here we make it 1, 0. 0 meter. Okay, look at what I'm trying to explain to you all. 6 plus 0.125, another 0.125, another 6, another 4. See that? If you're asked to find the total distance in the first 4 seconds, in the first 4, 6 plus 0.125 plus 0.125, okay, or direct plus 10. You got what I mean? But now a bit different, okay, because question asks about what, yeah? Okay, so I do it like this. T1, you're at 1. T1. T2, you're at 0. Okay, just like I said, 3 points, starting point, turning point, ending point. That one is for the first 4 seconds, okay? But now, since question asks you 2, 3, and 4. Sorry, 2, third, and 3, yeah? Okay, we see the difference, yeah? Okay, we go this one, first 2. Hey, yeah, wait, I make a mistake again. This one. Excuse me. Okay, ready? Here until here, T1 until, okay. So means T1, 6, 6, 0.125, 0.125. Again, see? Here to here, 6. 6, okay, see my cursor? I think I changed color. Here to here, 125, 0.125. Here to here also 0.125. Now this is how I get the first 2 seconds. 6 plus 0.125 times 2. Okay? Now, so you get 6.25 meter. Okay, got it, class? Roman 2 later, I go Roman 3 first. First 3. Now I go first 3. First 2 we have done, right? 3 is at 3 meter. Can you see that? 3 meter is here. Here. So I still need to add. Yeah. Can I see another 3 meter? Another 3 meter, right? So for Roman 3, 6.25 that we have done just now, plus another 3 meter. So you get 9.25. Okay, until here so far, is it okay? Yes, okay, so Sadhana, okay, not Sadhana until here? Yeah, okay, next. George, okay, Yansim, okay, na? Yeah, okay, now we see the third second, the third. Take note, most we have first 2, first 3, first 4. Now you look at the questions that stated what? The third. The third, okay? Yang ketiga, saat yang ketiga. Okay, you apply this formula. T3, remember? So you add S3 minus S2. Hope you still remember this formula, arithmetic progression, okay? Arithmetic geometric progression one, right? So S3, you got 3. S2, you got 0. So mean move 3 meter only. Actually, what this means, saat yang pertama, saat yang kedua, saat yang ketiga. The third one. The third one means S3 minus S2. So saat yang ketiga, it moves 3 meter. See, saat yang ketiga moves 3 meter. Sana, saat yang ketiga moves 3 meter only. Okay, got it, class? Okay, so write down and have a short break before I continue number 6, okay? Have a short break, yeah? Excuse me. Okay, class, we continue. I get ready to question 6. A particle moves in a straight line. Its displacement is the same given, okay? With the help of a graph, find its further displacements to the right. So to the right. You can use the number line or graph, yeah? Yeah, the question asks you with the help of the graph. So you can sketch the graph like just now. Okay, sketch a graph like just now to see until where the furthest one, okay? Now, so how? Again, class? Listen to me. I expand, T cube minus 8t squared plus 15t. So the same thing, we do ds dt. Only we can see the maximum or the minimum one, yeah? So when ds dt is 0, the maximum or minimum value, so you apply like this. Okay, so you factorize with a calculator, remember? Yeah, you find 3 equal, negative 16 equal. I hope you still remember, yeah? Okay, find the t, Nancy, with the quadratic equations. Still remember, yeah, equations? So 3 equal, negative 16 equal, 15 equal. I get 4.1 and 1.2. Okay, all of you can get this value? So same, when t is 4.1, when t is 4.1, you substitute to the s. Substitute to the s, huh? Okay, you can go t cubed minus 8t squared plus 15t. This one no need for me to show you, huh? You should know how to do already. Calculation, 4.1 equal. I get negative 4.059. Okay, key again. Calculation 1.2 equal. Calculation 1.2 equal. I got 8.21. Okay, anak kelas? Now, so when you're asked, okay, it's furthest. Its furthest means it will move to 8.21. 8.21. You can do like just now to sketch the graph that I taught you already. Okay, when t is 0, you're at 0. See that? Turning point means you can see which, like just now you sketch like just now. Lah. Okay, but I know that these two, this is turning point. Turning point. What do I mean by turning point? Okay, class, I use number line to show you again. Zero. And then we have one that 8.21. And one with a negative 4.059. So when t is 0, we are here. The particles is here. When t is 1.2, see 1.2, start to turn. Then after that, okay, go, same lah, move, until negative 4.05, it start to turn again. Means keep turning like that. Go turn like this. Here I got t is 4.1. Okay, now the particle moves like that. You understand, class? Cannot? Now let's say you find with the table, you can see t is 1, where is it? T is 2, t is 3, and so on. Yeah, but I just sketch these 3 for you first. Starting point and the turning point. Okay, ending point means the same lah. They give you this. We got two points here. Yeah, means it turn to the right and turn to the left. Okay, class. With the help of the graph, you are asked to find its furthest displacement. So I didn't draw the graph. Later you can draw it yourself. I used this number line to show you. You know how to convert to the graph in that class? Just with the help of graph, but question didn't say that you must draw the graph. You know how to get from the graph there? Okay, I show you the apaya. Wait for a while. If you have to draw the graph, you need all the points with the table. The points with the table. Okay, my space here limited class. I make use of this to explain to you first. Later, I convert it to the graph to show you, okay? Just a moment, yeah? Okay, wait, because I use this easier. Find the times when it is at O. Wait, furthest not yet. Furthest displacement, 8.21. Can I? Yang kejauh lah, 8.21, is greater than this. When it is at O, it is at O, not only when t is 0, you still need to find what is the t that makes it, okay, back to 0 again, like that, going this way. So that one you can use with the help of what? With the help of the table. Okay? So with the help of table later, still got some value, not yet shown. Just this point because I want to show you C. I make use of this because I want to show you C. Like what I said, most of the question will ask like section C, okay? I see now, class. Wait, I'll back to there. First five. Okay, we see? First five, First five means just now I got starting point, turning point, and ending point. I need to get when t is 5, where is it? T is 5, where is it? So when t is 5, okay, you substitute here and see. Substitute here, t is 5. Yeah, substitute here when t is 5. Yeah, I get 0, okay? Then some more we still have here. We still have here. Yeah, okay, for B lah. Wait, but I want to show you this one first, like class. Okay, listen to me. When t is 0 means it moves like this, Okay. Here, 8.21. Another 8.21. 4.059. Another 4.059. Until here, because T5 ending point. So class, okay, section C, we got the answer already. 8.21 and 4.059, you times 2. See, here and here, you times 2. Sorry. I got 24.538 meter. Okay, I do this part is when question asks total distance traveled in the first 5 seconds. So I go starting point, T0, turning point for these two. Sometimes you got one turning point. Here we got 2 turning points. And ending point when T is 5. T is 5 is here. Okay? So now I want to back to this part, section B. So is it okay understand until here? Yeah, right, class, you see section B. Section B, you do like just now. Form a table like just now. Okay, so it goes 0, 1, 2, 3, 4, 5. Okay, 5 with the calculator. TQ. Okay, key in again. Alphabet X cube minus 8t squared. 8t squared plus 15t. Calculation 0 equal, I got 0. Calculation 1 equal, I got 8. Calculation 2, I got 6, and so on, yeah? Okay, class there. T0, it's 0. T3, it's 0. T5, it's 0. But you notice or not, from this table, I can't see the maximum value, you notice or not? Yeah, and from this table also, I can't see the 4.059. That's why you know why sometimes not only you make this table, you have to do the number line also to get the dsdt, okay? To see the turning point. Okay, now, so class, with this, just now I say I want to help you with the graph, right? So you can do the same thing with the graph. Yeah, 0, 0, 1, 8. 2, you get 6. 3 is 0. 4, you get -4. 5 is 0. So you get this graph S shape because this is power 3. But here, okay, here, we do not know whether, okay, the maximum value, remember? Just now I taught you already, right? To get the maximum value is 1 point something, right? dsdt, right? And down here also, okay, we must get the minimum value. Just like I have shown you how to get 8 point what now? Forgot already. 8.21, yeah. 8.21. Another one that also I have shown you how I get negative 4.059 from the dsdt. So means you got extra value of this and extra value of this. Okay, then see your graph. Yeah, with the help of the graph, there you can see the maximum is 8.21. This is for section 1, just now with the help of graph, okay? Here, my graph a bit chacat, yeah? A bit chacat here. You sketch here, okay now? Because I simply put the scale there. I didn't measure carefully, accordingly, yeah? Okay, can follow so far question 6? Should be okay, right? Okay, so mark down 7 and 8 as homework. Mark down, yeah? Question 7, question 8 as homework for 8.1, okay? So same as my math. If I have done everything, I'll give you the set, okay, module 1, 2, and 3, and so on. Then we'll start to do the revision, yeah? Okay. So any question to ask? Is it okay for displacement, the graph of displacement time? Yeah, okay, next, get ready to my 8.2. Okay, what is the difference, 8.2? Okay, before I start 8.2, you got SVA. Always I ask my students to remember this. SVA. Displacement. Okay, displacement. V is a velocity. Acceleration. When you go this way, From S to V, you differentiate. From V to A, like this, to the right arrow, you differentiate. Then vice versa. Left arrow, you do integration. Integrate. From left to right, differentiate. Right to left, you integrate. Okay, now so later, how we're going to use this one, I'll show you. Okay, class. Get ready, question 1. A particle moves along a straight line given as. Okay, so what did I ask to find? Find the velocity, see? I just remember I said SVA. SVA. You asked to find the velocity, you have to do the differentiation, differentiate, So to get to get V, you differentiate ds dt. 12 minus 2t. Okay, so Roman 1, 2, 3 should be okay already. And t is 1. Then you get 10 meter per second. And when t is 2, and when t is 3, sorry, not 2, not 3, I make a mistake. Should be 4 and 7, sorry. Okay, now you find the velocity. Actually, this is to practice your from S, you change to V, you differentiate. Okay, got it, class? Here, I got 4 and negative 2. Yeah, okay, class, take note now. When V that is positive, means the particle moves to the right. I didn't use the O. When negative, the particle moves to the left. If moves to the right of O or left of O, that one is S, displacement. When move to the right, move to the left without mentioning the O, this is velocity. Okay, can you see what I mean? Yeah, now look at B. Find the time when the instantaneous velocity of the particle is negative 6. Negative 6. Okay, means what? Means when V is negative 6, then the V, right? Then for you to find T. Okay? Just direct to your calculator of alphabet. Or just do it manually. Should be okay. Okay, so what do you get? Negative 6, negative 18, yeah, 9, okay? 9 seconds. And, okay, continue, we have a look. The instantaneous displacement of the particle when V is 2. This means what, you know, class? When V is 2, you find the T. When you get a T, you substitute to S. That's what I mean? Find displacement when V is 2. Okay, we see back here when V is 2. Yeah, that T is 5, right? T is 5. When T is 5, we substitute here. Okay, you substitute here. So I get the displacement. 68 minus 25, I got 43. So this exercise 2, we mix already. S and V, not yet to A. Not yet to A. We just Section 1, just now 8.1, we learned about displacement. Now 8.2, beginning, we learn about S and V. S to V, you differentiate. V back to S, later I'll teach you how to integrate. Okay, can follow so far until here, class? Can I have a response? If not, I keep giving you some other example. If okay, I continue. Can I have a response, yes or no? Can follow all of you? Yes, okay, but some not yet giving me any response. Whether can follow until here? George, okay. Yensim, yes. Chiat, okay. Ray, okay, Sadhana, okay, not? Okay, Okay, good. Okay, now we continue, yeah? And look at number 2. Okay, so you just read, okay, as given. As given. Find what? Can I see find velocity? So it's the same, like number 1. Okay, this one, I leave it to y'all. You find V, do ds dt. Then when t is 5, say that, okay, when t is 5, you substitute here to get the velocity. Okay? Next, what about B? They asked to find the velocity when the displacement is 22. Actually, class, what all you need is given what to find t. After you get t, substitute to what? Now, so you are given displacement. You are given displacement that is 22. So you substitute here. Substitute here to find what? To find t. To find t, then do what? To find t, then substitute to velocity. And take note, class, t with a negative, you ignore. T can't have negative, okay? Same, okay, find what? Find the time. Given what? Given velocity is 3. Then the velocity here, for section C, you are given when v is 3. When v is 3, okay, when v is 3, you substituted the velocity here, you find t. Okay, now? Okay, have a try and see. Yeah, lah, ds dt, just differentiate. Okay, have a try question 2. So I just try to answer here, 15. B, 11. C, T is 2. Done, yeah? Okay, good. Can get answer, yeah? Okay, good. George, Ray, done, yeah? Yes, I can get, okay. And Sim done, yeah? Okay, good. So I think all of you can get right. What about you, Chia? Yes, huh? Okay, good. Yes, huh? Most have done. What about any of you still? Any of you couldn't get answer? Which one that you all need help? What about you, Sadhana? Done or still? Need help or not? Sadhana, need help or not? Done or still? Okay, done, yeah? Oh, still is it? Okay, wait for you. For you that have done, you can proceed to question 3 while waiting for still got students that know they're done, yeah? If you need help, you tell me, yeah, Sadhana? Okay, done, yeah? Okay, good. So can get, very good. And now we continue. Number 3, I just briefly explained. Same, I will leave it to y'all. I'm not going to wait for y'all to do here because I'm going to continue to explain. Then you are given V as right. So if you want to mark down anything, you follow just some step that given. Yeah? As given, then find velocity. Means you do the SDT like just now. Then after you get a velocity, you just substitute when t is 1 and when t is 3. So assume motion to the right is positive. You notice or not? I didn't use the right of O. The right of O is displacement. So when t is 1, you substitute to here. And when t is 3, you substitute to here. Okay, you got us assume to the right is positive. Let's say you got a negative answer, you just say to the left. And you got a positive answer, you tell to the right. Okay? Get what I mean? Okay, I show you one of it now, see? So I got 3t squared minus 8t plus 1. See? And so for section A, when t is 1. 3 minus 5 plus 1, I got negative 4. Negative means to the left. Cannot to the left because positive is to the right. Okay, can follow, yeah? So B, you can mark down B as homework, question 3 now, yeah? Okay, listen to me, question 4. Question 4, I will show you how to do. Yeah, you are given as same, right? See the word velocity? So once you see the word velocity, okay, I know that I need to get V, that I do ds dt. Yeah, ds dt. So you get 2t squared, number 5, number 4, right? Okay, 2t squared, 7t plus 3. Okay, class, look at A. Can you see the word initial? Yeah, initial means when t is 0. When you see the word with, yeah, initial, then you can find V. Okay? When t is 0, then you can get 3 meters per second. Find the time when a particle is instantaneously at rest. Okay, class? Learn another one, yeah? Rest. What do you mean by rest? So if it's at rest, okay, take note, not moving, V is 0. When you see the word rest, when you see the word not moving, when you see the word stationary, I repeat, rest, not moving, stationary, means V is 0. When V is 0, so you substitute here, class. Substitute here. I mean here, 2t squared minus 7t plus 3 is 0. Okay. So for this one, you can get from a calculator. Okay. To factorize, remember? So you see from a calculator lah, yeah. 2 equal, -7 equal, 3 equal. I got 1/2 and 3. Okay, now? Now, why I want to factorize here? Because I want to show you something. See. These are all these you learned before. Okay, see here. Find the range of time which a particle is moving to the left. To the left means negative value. Okay, at class, I hope you still remember this one you learned in Form 4. I sketched the graph with the time of 1/2 and 3. So remember I told you before, this one is a negative value. Here, positive value, remember? So question said to the left means negative value here. Here. Here, so means that I factorize already. So the t lies between 1/2 and 3. Okay, now? So take note, lies between 1/2 and 3. Can you understand? Chia, what do you mean? Oh, okay, yeah. We don't put all equal here because question didn't mention. So question didn't mention, we just use this range only. Okay. If here, see, I change it to the particle, okay, class. Listen carefully. You might have this type of questions. I make use of this to explain to you all. If question say move to the right, see how I write? These two region, right? So class, take note. If move to the right, normally in Form 4, you learn these two region. But for this chapter, take note of this. Take note of this. Any that the time to the left, you have to make it a stop at 0. Make it a stop at 0 because time can be 0, but time cannot be negative. That's why you see I put smaller or equal 0. Smaller or equal 0. If you are asked to find moving to the right. Okay, got what I mean? We still have this type of questions. I'll alert you again, okay? So far, can you understand, class? Okay, Anna? Any question to ask? Yeah, so can I delete? Okay, I have one more to go for question 5. Okay, same. Listen to me, There you are given a S. Okay, see velocity? So I just catch you. I'm not going to solve for y'all. Same lah. Find V ds dt. Get the velocity. Then after that, can you see the word initial? Initial? Initial means when t is 0. You substitute to get the V. Okay? Yeah. This one, what I'm trying to explain to you is B. Show that, see the word show, that the particle is moving to the right at all times. Okay, moving to the right at all times. Remember B squared minus 4AC? Moving to the right means what? The velocity that is always positive. Plus, if the velocity that is always positive, the graph of your velocity and time will be this way. Will be always positive. Cannot cut the x-axis. No zero, no negative. Because zero is not positive. Okay? So move to the right. Move to the right means the velocity must be all the while positive. So what is this graph? Remember? You have learned in Form 4 also? When you see the graph like that, remember, you have to prove that B squared minus 4AC, that is always -1. Okay? Does not cut the graph, right? Remember? So what do you need to do? From the velocity here, okay, velocity that you get, you apply. You explain yeah, for V that always greater than 0. You copy what you have here. And then you do B squared minus 4AC until you get the negative value. Okay, for example, here you get -19, I say. So you explain B squared minus 4AC, that is negative. Does not cut the x-axis. Does not cut the x-axis. So this one proven already. Proven already. The particle is moving to the right. The particle is moving to the right at all times. The most important is to show this one. Yeah, to show this, then you give explanation. Okay, you give explanation, you copy, you say that. After you get this, you explain that the particle is moving to the right at all times. Okay, can follow so far? Yeah, so class, mark down. Just like I said, 8.1, question 7 and 8 as a homework. 8.2, question 3 and 5 as your homework. Okay, so I teach you until here to be continued next week, yeah? Okay, so still have any question to ask? If not, you're allowed to leave, See you, bye-bye.